Find the radius and interval of convergence of the following power series. We have sigma n from 0 through infinity of -1 to the n x raised to 2n plus 1 over 2n plus 1 factorial, and we always assume everything here as an, okay, and use the ratio test for convergence. So limit of an plus 1 over an as n goes to infinity, that is same as limit n going to infinity of an plus 1. This is an, so an plus 1 would be replace n throughout by n plus 1, so -1 raised to n plus 1 times x raised to 2 n is n plus 1 plus 1 2n, n is updated with n plus 1, okay, over 2n plus 1, this n should be n plus 1, so 2n plus 1 plus 1 factorial, that's an plus 1 divided by an, which is same as multiply by the reciprocal of an. So take the reciprocal, so this goes on the top, 2n plus 1 factorial on the top over -1 to the n on the bottom and x raised to 2n plus 1 absolute value. Let's evaluate this limit, and we need this limit to be less than 1 for convergence, okay. So that is equal to now limit n going to infinity of, when we take the absolute value, this -1 raised to n plus 1, that's the positive negative always becomes positive, so this will be just 1. Same thing here, so this will be always 1, this will be always 1, so basically they are gone. Now let's simplify this, so x raised to 2n plus 2, so we need to distribute 2n plus 2 plus 1, so 2n plus 3, that's x raised to 2n plus 3, which is same as x raised to 2n times x raised to 3, okay, over this is we need to distribute here as well, 2n plus 2 plus 1, so 2n plus 3 factorial divided by, we multiplied by the reciprocal, okay, here is 2n plus 1 factorial divided by x raised to 2n plus 1, which is same as x raised to 2n times x raised to 1, or just x, okay. Now we can cancel x raised to 2n from top and bottom, and 2n plus 3 factorial, 2n plus 1 factorial, oh, x cube x, we can cancel 1x here, 1 copy of x, now 1 copy, so just 2 copies left, and 2n plus 1 factorial, 2n plus 3 factorial, this is bigger, 2n plus 3, so let's expand to 2n plus 3. So we know 2n plus 3 factorial is same as 2n plus 3 times 1 less, which is 2n plus 2 factorial, or 1 less all the way, 2n plus 3, 2n plus 2, the next 2n plus 1, which we have here, so 2n plus 1 times 1 less all the way to 1, or we can stop here, right, factorial, okay. So this is limit n going to infinity of absolute value, we have x square and 2n plus 1 factorial divided by 2n plus 3 factorial is in fact 2n plus 3, 2n plus 2 times 2n plus 1 factorial, okay. Then we can cancel 2n plus 1 factorial, 2n plus 1 factorial from top and bottom, and absolute value of x square is always positive, so are 2n plus 3 and 2n plus 2, because n is going to infinity, so we don't need absolute value anymore, and this limit is independent of x square, so we can pull all the way outside x square. Okay, and we have limit and going to infinity of nothing left, so 1 over 2n plus 3 2n plus 2. Okay, let's find this limit, and when n goes to infinity, the bottom goes to infinity, infinity times infinity, so 1 over infinity, that's 0, so this limit is in fact 0, and 0 times x square is just 0. Okay, so the limit is 0. So, and we know that 0 is always less than 1 for any x value, regardless of the value of x, this limit is always less than 1. That means this power series, okay, this given power series converges for all x value. Okay, so for all x value, if we look at here, number line negative infinity through positive infinity, and by the way the center was x minus nothing means center was 0. Okay, and the radius of convergence is infinity, and interval of convergence is all the way negative infinity through positive infinity. Okay, because we got the limit 0. Radius of convergence, okay, I'm writing just convergence, that's we denote by r, that's infinity. That means this series converges for any value of x. If we put any value of x, then this series has a finite sum, and interval of convergence is negative infinity through positive infinity, final.